Hello again, Chem A students. If you're ready for this video, that means you should be in section B of Unit 3, and hopefully you've done the energy reading that was posted, or you got a paper copy. You read about ways that energy is transferred, ways that it is stored, and so right now I'm going to give you a little bit of follow-up information just so I can highlight those important terms that you need to know so that you can go on and be able to do some more stuff with that. For example, this is Learning Goal 3.7, and so what we're trying to get to is to be able to label some graphs and charts for things that are having some energy changes occur due to temperature and changes of state. And so there's going to be terminology that comes up and that gets labeled with that you need to know, otherwise it's not going to make any sense. So that's why I had you do the reading, and that's the purpose of this little follow-up information about those key terms. So good time to take notes or add to the notes that you took in the reading or the questions that you answered for that. Actually, before I click to the notes, it's a very exciting day because I have something for everyone. I have $100 to give all of you. You're such great students, you've been working so hard. I thought, wow, you know what, you need a little bit extra just to make up for all the time you've been putting in. So $100 for you. Some of you are going to get a $100 bill. Hopefully you can see this. I don't know if you can see it or not, but look at that, $100 bill. Now, some of you, I think, I don't have enough $100 bills, but some of you are going to get two $50 bills. So same amount, but two $50 bills, $100. Some of you, though, I'm going to have to resort to a check method. So look at this, check to you for $100 signed by me. So all the same amount of money, different forms. Some of you might put that in your billfold. You might store it there. Some of you maybe want to take it right to the bank and store it there and save it for some future use. And then later, maybe you could use a little plastic card that you have. I don't have one here, but an ATM is a way to transfer that back out. And even though that card looks very different from this $100 bill, it really represents the same thing. Maybe some of you will take your $100 bill and put it into the stock market. And then maybe you'll get a piece of paper that says something about what you've gotten. But again, it all comes back to the same amount of money, even though you might store it in a different place or you might transfer it around in a different place. Some of you will probably transfer this $100 I give you and maybe go buy a new video game or whatever. And even though that video game looks very different than the paper bill I gave you, it still represents the original form and that you have transferred it into something else and now it's being stored into your fabulous video game. All right, so I'm going to switch over to some notes. Hopefully you're not so excited about this money that you're going to get that you're not going to pay attention, but here's the point I want to make, first of all, is that money can be stored in lots of different accounts. In fact, we have, bank accounts. Even in the bank, we have separate accounts. You could store it as cash. Maybe you're going to put it in your mattress at home. Energy is the same way. It's stored in lots of different accounts. And the big point here is that no matter how we store our money or what we do with it, it still represents the same thing. We might have it in different quantities at a time, different amounts of bills, or it looks different, but it all represents the same thing. And the same is true for energy. In fact, the energy that you learned about in biology is the exact same energy we're talking about here today. It can be stored in different places, but it still is energy. Energy is energy is energy. And so one very important thing that you need to understand are the places that energy can get stored with substances. And one of those that we're going to deal with is thermal. So the abbreviation that we're going to use is capital E and then the TH that follows that. E for energy. And all of these, you're going to notice, start out with E for energy because they're all energy. This one happens to represent the one that's stored as thermal. Thermal energy is energy that's stored due to the motion of particles. All substances, their particles are moving. And it really depends upon mass and how fast they're moving, how much energy is stored in thermal. The way that we are able to take an observation of how much energy is stored in thermal is through temperature. A really high temperature reading tells us there's a lot of thermal energy being stored there. Very low temperature means a very low amount of thermal energy. All right, another one is interaction energy, and notice E, big E for energy, and this one is specifying where that energy is being stored due to interaction. And this really has to do with the interaction between the particles, how the particles are arranged, and how much they're able to interact with another. So that's why the description here says due to arrangements of particles and attractions between each other. The way that we can take an observation to know about how much energy is stored as interaction is through the state that it is in. And when I say state, I'm talking about, is it a solid, is it a liquid, or is it a gas? And here is the progression of that. Solids have a much lower interaction energy compared to the other two, so I put a less than in between those, because those particles are in a fixed place. They can't even touch each other. They might be vibrating in place, but they have very little interaction with their neighbors. Liquids, on the other hand, have much more interaction with one another. They can bounce off each other, slide past each other. And then gases, of course, have even more interaction between another. Lots of movement between particles. So if something's in a solid state, very low EI, very low amount of energy stored in interaction versus liquid in a gas. Gases would have a lot of interaction energy stored. The last one is chemical potential energy. So notice E and then CH for chemical. And this is due to attractions within molecules, not between the particles, but within the particles themselves. And so the observation that we can take to know what's going on with the chemical storage is if there is a change in compounds. And I'm going to be honest, this is something that we're actually going to deal with in units down the road in Chemistry B. Right now, the storage that we're going to focus in on is right here, the thermal interaction. But I bring it up now so that you're aware of there is other places that chemical energy is stored, or energy is stored, in this case chemical energy. We're going to ignore any changes that occur, because again, that comes later. So this highlights places that energy can get stored. Okay, next I'm going to talk about transfer that you read about. And again, just like money can be transferred, like from me to you, or you to the goods that you buy, or you put it in the bank, or you transfer it to different accounts, and it still all represents money, energy is the same way. It gets transferred all around, but it retains its identity of being energy, even though it might change where it's being stored. And so just like there's different ways to transfer money, different ways to transfer energy as well. And these are the big ones that you read about, and I just want to highlight here quickly. One of them is due to heating. And if something gets transferred, or energy gets transferred due to heating, it's because of collision of particles. Particles colliding with another particle, causing them to move more, which then in turn they hit other particles, they move more, and so on and so on. So it's the collision of particles that transfers that energy, and we call that heating. And the abbreviation that we use for that is a Q. So when we want to label something that gets transferred due to heating, collision of particles, we're going to label it Q. Working involves forces between large objects, not at the particle level, particles hitting each other, but large objects, large cars moving, or you yourself picking up a box and moving it to another place. And the abbreviation for that is a W. And I'm going to be completely honest here, bringing this up because you need to be aware that it is a way that energy gets transferred. This is a physics topic. So for those of you that plan on taking physics or are thinking about it, this is a big topic of how energy gets transferred in physics, because physics is a part of science where we look at big object interactions versus chemistry where we're looking at particle interactions within the objects. Last way that, main way that energy can be transferred is through radiating. And so we abbreviate this with an R. And I put light here as an example, but this actually means anything that is an electromagnetic wave. And light, the visible light that we see, allows us to see objects, is an electromagnetic wave. But there's lots of electromagnetic waves. For example, radio waves are an electromagnetic wave. X-rays, ultraviolet waves, gamma rays, those all transfer energy from one object to another. It's the way that we get energy from the sun, is by radiating. And so that's labeled with R. Again, this is more of a physics topic, but I need you to be aware that it's a way that energy can be transferred. The thing that we focus in on in chemistry is right up here, this heating, collision of particles, because again, chemistry is about the particle level and what's happening within substances, not between substances. So the only one you really need to worry about is this heating due to collision of particles. All right, so if you understand those terms, you're ready to be able to know how to put changes with the terms together in energy bar charts. And so there's a little tutorial video about that and some practice that you can do that you're going to apply to the Icy Hot Lab that's also part of this section. Okay, and look for this in the mail. Spend it wisely.